My name is Fred Hyatt, and I come to this introduction to evaluation from a very different perspective than my classmates. I have a background in mechanical engineering combined with an MBA, and I have spent a number of years in the electronics and semiconductor industry developing technical products and marketing them. And so that's my backdrop as I approach this introduction to evaluation. I studied not only Dr. Patton's book, but also shared with the class some of the insights of Jonathan Morrow's book, Evaluation in the Face of Uncertainty. And so that combination and that background led to my mind map that I'd like to share with you today. In addition to that background, let me tell you that my life has been full of comparisons. Our professor, Dr. Williams, began by describing or defining evaluation as a comparison with what is with what should be. Now, my life has been full of comparisons. I'm a twin, so that automatically gave me comparisons throughout my life and continues to be. And if it wasn't being compared with my twin, my next younger brother looked more like me than my twin and was always about my same size, so I was compared with him. And if not those two, I have 8 other brothers and sisters with whom I could be compared to. I'm number 7 of 10, so there were lots and lots of comparisons throughout my life. And I developed an attitude or a value system that my potential compared to where I'm at was basically a stepwise progression. And the real key to success in life was finding that next step and moving beyond my current existence, and thereby maximizing my performance relative to my potential. And as an engineer and my educational background led me to a metaphor, if you will, using mathematics to express the concepts of evaluation and to help me visualize how my values are reflected in evaluation or how my values influence evaluation, but even more so, how can I better evaluate my progress or my growth from where I am compared to where I would like to go. Initially, I thought of a very simple characterization, me being that point there in the center, a single location, time and space, compared to what I hope to become, a very limitless opportunity to grow and develop and flourish in many respects. That suggests to me that it provided me with some information about this system of values or opportunities, but it really didn't help me determine where do I go from here? What direction should I pursue? And so then I thought about a two-dimensional view. And you can see I grabbed 2 obvious ones, growth in the x-axis over time in the y-axis, and that began to give me a little bit more sense of direction, a little bit more idea of comparing where I am with where I would like to go, or in any other choice or comparison in evaluation. Very simplistic model for, okay, if I discover point X, then I can reference point Y. And so there's that corresponding look. But of course, this obviously has its limitations, especially in the dynamic world. And I'll talk about that more, as has been referenced already, and is such a key point to developmental evaluation. One aspect that I thought of as I considered this was a principle in calculus, which says that if you want, for various reasons, and if the model is appropriate, you may want to choose to measure the area underneath the curve, or quantify the growth to date, so to speak, or the progress made. And the very simple principle is you slice up the area into equal size slices and then estimate the area of one slice and then add up all the slices. The theory being that if the slices become infinitesimally narrow, then you get closer and closer to an exact number. And so I thought, oh, well, that tells me to date or some point in time I can add up all the areas under the curve and say, okay, to date I've made this much growth. And I thought, well, that kind of parallels some of the more traditional forms of evaluation where you simply say, okay, today we're here at this point and we want to add up all the progress or the growth and say, okay, here's a number. Here's your evaluation, here's your score. To date, your program has accomplished this much value in that sense. And I thought, oh, well, now I'm beginning to grasp this and understand. But as we continued and understood more about the participatory nature of developmental evaluation and also the dynamic aspects of systems, this obviously became very inadequate. So I turned to another more advanced engineering concept, which says that if you represent many variables, that you can also define a surface, and then to visualize that surface, which maybe is composed of lower points or minimums and maximums in some kind of not a random fashion, but the mathematical expressions, a multivariate expression, gives us that surface, and then we look at that surface and say what is desired. And in most cases, we want to either locate those minimums, either in an absolute sense, or locate the maximums in an absolute sense. It may be helpful to, if those absolutes cannot be chosen, then maybe a relative minimum or maximum would be desirable, depending on your location at a given set of variables or given time, if that's one of the variables. So this began to say, okay, now we're starting to see a broader picture, a more complete picture of the real world or the considerations that must be taken into account when one does evaluation. And in fact, the question then becomes, how do we find and how do we identify those maximums, or how do we identify where we are relative to those maximums or minimums, depending on what we're trying to accomplish. In the case of an engineering model, we may want to be maximizing strength or minimizing failure or some other parameters that are expressed by our mathematical relationships. Optimization theory suggests that if you identify your starting point or where you are at a given point in time, then you can go through a series of iterations and search values in the immediate vicinity of where you are. And then you get increasingly wider search patterns, and then you can identify from this point to a successive point, is the change desirable or not? And so then you move to that more desirable point and you begin again and iterate in the near vicinity of that point, and then you iterate a wider and wider circle, and then you find, for example, am I dropping down to a minimum or am I approaching a maximum? And so there's this iterative process to determine those minimums or maximum, depending on what you want to. And this seemed to resonate with some of the aspects of developmental evaluation, where in the beginning you're not even sure where you're going to go necessarily, but you work with the individuals, you work with the program, and you identify the characteristics that are useful and maybe help them identify the directions they're going and approaching some ideal or more desirable state. This also seemed to resonate with Jonathan Morell's concepts of uncertainty. And he describes, and I'm quoting here, how leading indicators of a system-based logic model can help the evaluator in identifying sources of surprise or uncertainty, and thereby enabling the evaluator to more accurately predict the impact of those potential uncertainties on the system or on the outcome. And so again, not knowing whether I'm going to encounter